David, can you give me the numbers for the middle school for the inventory? And then for the high school? And then David, one more question. What would the dimension of that matrix be?
That would be
Yeah, so close. 2, 3. So there are 2 rows and 3 columns. Rows, you go across left and right. So I have 1 row for the middle school, 1 row for the high school. But we have 3 columns because we have sweatshirts, t-shirts, and pennants. When you look at the cost matrix, does anybody know why the cost matrix is listed up and down instead of it being listed left and right? Virginia? What would the dimensions be as it's listed going vertical? How many rows are there in this matrix? 3. And there's 1 column. So the matrices, remember from yesterday, if I'm multiplying them, the columns of the first must match the rows of the second in order for us to multiply. If my cost matrix was written left and right, I wouldn't be able to multiply them together. You physically can't do it if it's a 1 by 3 matrix, which is why that cost matrix is listed vertically and not horizontally. And that kind of goes along with the number 33, I think, from your homework last night. So the cost of my t-shirt or sweatshirts 15, t-shirts 9, pennant 5. So we can multiply them. When you multiply them, your dimensions are the outside numbers. So my new matrix should be 2 by 1. So the end result should be 2 matrix 2 by 1. Question? You're going to give me the matrix? Before you do that, so if I have 2 rows and 1 column, I only have 2 numbers that should be left after we do the multiplication. Remember, you're going across a row and down a column. And it's always rows by columns, rows by columns. So if I move across my row here, I have a 61. It gets paired with 15 because they're in the same position. So first position, first row, first position, first column. And then we have 63 with 9. That's the middle value. Again, they are matching each other. First, second, and the second. And then the last one is the 74 with the 5. So that would be the third position in the row, the third position in the column. 1 number matches with 1 number from each column and row. I don't have another column to go down, so we just move to the next row and multiply that row by the column of the cost matrix as well. So we would have 58 with 15, 71 with the $9, and 92 with $5. So if you're showing your work, you should be kind of looking and seeing that your column is still written there vertically in the work. And that'll happen every single time if I'm multiplying across but down a column. So David, when you add all this information together,
1,852 and 1,000
so say the first number again.
1,862.
Okay, and then the second number?
19,000.
52?
You said 19.
That's what okay. I think, yeah, that's what I just wanted to hear. So what do these numbers represent? Sarah? Total cost. And if it's a word problem and you're talking about total cost, your units should be dollars. So whether you want to put the dollars inside the matrix, my matrix is now 2 by 1, or you want to put them outside, but somewhere you need to make sure that you are answering the question. Cost, inventory, money needs dollars. So the high school inventory cost is $19.69, the middle school inventory cost is $18.52, and that would be in dollars. Questions? So keep the packet to the side. I wanted to look at number 31 for your homework before I collect it.
Oh, where did you see my phone?
So number 31 was an equation matrix multiplication problem. So had x's and y's, you had to multiply, but you also had to solve for the x's and y's in the problem. So this is what 31 looked like. It didn't give you separate matrices, it already had it written as an equation. How do we solve for x and y? So think of the equations that we solved with the addition. How would we solve for x and y here, Sarah?
First you multiply the two matrices together.
Yeah, so if it was an addition sign, we would add the matrices together provided that they were the same dimensions. Since it's multiplication, on the left side, we still have to combine these matrices together. There is no dividing by a matrix. So the left side of this equation, we need to combine them together by using multiplication. So just checking here, we have 2 by 3 because 2 rows, 3 columns. And then my other one is 3 rows by 2 columns. So my end result should be a 2 by 2 matrix, which is good because that's what the answer is on the other side. So it needs to match up with the 2 by 2 matrix on the other side. Otherwise, we can't solve for x and y. So 2 rows, 2 columns, they should be equal to the y4, negative 13, and 8. So yesterday, working with matrix multiplication, we always go across and down. So here's my row. I need to go across the row and then down both columns this time since there are 2 columns. So Kate, can you give me some numbers here that would be attached together?
You have 4 times 9 and 1 times 3, 1 times 2, sorry.
Okay.
And 3 times negative 1.
So that would be first column and the first row. So first row, first column. Moving across to the next row. Kate, can you give me that list as well?
You would have 4 times negative 2.
Okay.
And then 1 times 1. And then 3 times 1.
Excellent. So across the row, once you finish that row, you use it with both columns, then you move down to the next row. And that next row gets attached with both columns as well. So Ryan, what would that one look like? So start with the negative 2. Good. Go across the row. The next one is yep, x times 2. And then the last number, 1 times negative 1. You said it right. So now we're going back to the negative 2, but down the second column. I'm going to keep picking on you, Ryan. Good. Good. Any questions there? So across and down. The numbers get paired together that are in the same position. So if it's in the second spot of the row, I need to be in the second spot of the column. So now we need to kind of do a little bit of simplifying here, combine these numbers together. Isabella, how's your mental math today?
Let's go for it.
Okay, so we have 36.
Plus 2 minus 3.
So what would that give us?
That would give us 35.
Good.
Negative 8 plus 1 plus 3. So negative 4.
Awesome.
Negative 18. I'm going.
Maybe I missed a negative sign somewhere. Yeah. Okay, sorry. So negative 18
Plus 2x.
and a minus 1.
So that would be 2x minus 17.
together. They're different terms, a variable and a number.
And then 4 plus x plus 1. So 5 plus 6.
Perfect, or x plus 5. Nice job, Isabella. Any questions with that? So we've done the multiplication part. We now have one matrix equal to one matrix with the same dimensions. The last thing we have to do is solve for the x and the y. So Paige, how would we get the x or the y values?
Well, the y is just 35 because it's in the corresponding spot.
Okay.
And then to solve for x, you would put 2x minus 19 equal to negative 13.
And x is
X is positive 3.
positive 3. Check yourself, because if I plug positive 3 into the bottom right value here, 3 plus 5 also equals 8. So it should work in both of them if the x's are in 2 spots. That's a way that you can check to make sure that you didn't make a mistake somewhere, because your solution for both should be the same. Any questions with that? Okay. So I'd like you to place the name at the top of your homework and pass it forward. You do need a calculator today, so if you could take your calculator out after you pass your homework forward.
Miss Kate, do you want to do 3 problems?
Yes, please, yes. Are you ready? Alright, so in your packet, if you look at page 25, the last section of the chapter, I think we're good. Go. Alright, so this last section takes the information we've kind of talked about with matrices and applies it to solving a system of linear equations. So we know we can solve a system with, yes?
Can I go to borrow a calculator from the library? Or just for me?
I'm sure you can. I'll give you one now to use.
The library.
I mean, I know
Virginia?
Go to the library.
We did, yes. They do have them. Alright, so solving a system of equations can be done with graphing, substitution, elimination, but matrices would be a final way to solve a system of equations. I'd say for 2 variables, not necessary, but maybe for 4 or 5 or 6, which you'll do next year, totally necessary. So we're going to show it with 2 variables, just to kind of give you an idea as to how they can be used. And we're also going to be using the calculator with that. But before we get there, we need to talk about an inverse, and specifically a multiplicative inverse. But we'll go with the inverse first. What is an inverse of a number? Ethan.
Opposite.
The opposite. So if I gave you the number 2, what would you tell me the inverse is? Not negative.
Oh no, 1
1 over 2. Okay, so those are inverses. Virginia, give me another inverse. 5 and 1/5. If I multiply 2 inverses together, what is your answer always every single time? Okay? 1, no matter what. So no matter what, the inverse is always equal to 1 when you multiply it by the original number. So the multiplicative inverse kind of states that when you take an inverse and a number and multiply them together, you always get the value of -1 or a +1. There's one other thing here that I want you to kind of think about. If I have 1/2, but I want to write it as 2 to the -1, does that mean the same thing? Okay?
Yes.
So if you plug it in your calculator, if you're not sure, remember I'm going to lie to you. I mean, I should be fired if I'm lying. But check it in your calculator. So if you take 2 to the -1, does it equal 1/2? Yeah. If I did 5 to the negative 1, it should also equal 1/5 or 0.2. So inverse notation is that exponent of negative 1, and we'll be finding inverses of equations later on. Sometime in chapter 5, I think we'll start finding inverses of equations. So the multiplicative inverse says if you take any number, and I'm just using a here, and multiply it by its inverse, which is a to the negative 1, so that's inverse notation, that number will always be equal to 1, no matter what. A matrix also has an inverse. And if you want to look in the book later on tonight because you're interested in seeing how that inverse is calculated, take a peek in your book. But we skipped 3-7, and you need the stuff from 3-7 in order to algebraically find it. So it's like a 3-step process, totally doable. But as a department, we just chose not to teach that. Would I have done it? Probably, but I don't always win. So sorry for you. But we're going to find it with the calculator, which is easy, doable, and it works pretty well. So if you can take out your calculator, we are going to try and find the inverse of matrix A. So I would write A negative 1, and we're going to see if we can figure out what that is equal to. So the way to use your calculator, there is a matrix button on your calculator, and it's actually with the x negative 1. So if you hit second x negative 1, a screen pops up with matrices. I have A through G up here, but it actually goes, there's more of them. Move over to edit, because I want to put numbers into the calculator, and hit enter. Now my dimension is already up here, but the dimension of matrix A is a 2 by 2. So we always need to put the dimension in so the calculator knows how big the matrix should be. When you enter that in, it then bumps you into the matrix that has 4 numbers in it, because a 2 by 2 matrix should have 4 spots. So we're going to put the 3, 8, 2, and 5. And remember, it's going across the row, and once it's finished with the row, then it jumps down to the next row. Make sure you hit enter after each time. Questions with getting the numbers in there?
Yes.
Yes.
When you do that.
So second x negative 1. Go over to edit. Hit enter. And then you need 2 by 2. And 2 dimension. Anybody else? And then plug in the numbers even. Alright, so I'm going to hit second quit. Whenever you do second quit, that takes you back to your blank calculator screen. And we're going to now pull the matrix in. So we have the numbers, but we want to actually apply the inverse to that matrix. So one more time, if you hit second x negative 1, the numbers are already in. I don't need to edit, but I want the actual matrix that I put the numbers in. So I'm on matrix 1, I'm just going to hit enter. And now that matrix is in my calculator screen, so the calculator knows I'm using matrix 1. We want the inverse of it, so I need to hit the inverse button on the calculator, which is x negative 1. And then when you hit enter, you will have found the inverse.
Well, what?
I love how everybody goes, ooh, oh, and then like I got away.
Enter. And then
Whoa.
I'm gonna go after.
Like just the negative. Yeah, then you use the click the X.
Caitlin, check yours.
Ah, there we go.
So please write down that in the inverse matrix, please write that down in your notes if you haven't done so already.
separate this out.
I think you multiply by
That's a small.
questions? I'll be over. Aaron, just give me a minute. Alright, so we're gonna try example 2, which is now in equation form. So we're gonna use the fact that we can find the inverse with the calculator, but we're gonna try and solve an equation. So when you solve an equation, just real basic, like 2x equals 5. How would I get x by itself? Okay, divide by 2, or if I wanted to use the inverse, we would multiply by 1/2. The reason we do that is because we want to get x by itself, and when we take 1/2 times 2, we know that equals 1. So that's our goal, to get x by itself or to get a 1 in front. We're going to use that same information here. So if I have an equation, x is a variable, and if I need to find x, I can't divide by a matrix, but we can multiply by the inverse to get rid of the matrix or to take it to the other side. So my variable can be found by taking the inverse times the matrix on the other side. Because if I multiply something on both sides, then I'm keeping the problem equivalent. Like to solve this equation here, if I multiply by the inverse of 1/2 on one side, I multiply by the inverse of 1/2 on the other. So in our calculator, we're going to take A, which is 2, -7, -1, and 4. We want the inverse of that, and we're going to multiply by B, which is -21, 3, 12, and -2. That would be equal to whatever my variable x matrix would be. So see if you can try and plug the matrix A in the calculator and the matrix B in your calculator. So try and get that in your calculator, and then we'll see if we can find a solution matrix. Question? Okay, so second matrix,
You're just so
and then
good
just
on
inverse.
it.
And then I want to take the inverse of it.
You just in the metal. What's the best?
Wait, who's getting
Just
So we're making a new value for it.
We're finding the inverse of it. Yes.
Oh, okay. But
Because
wait,
that's how I would,
how do you write down the inputs?
we need to calculate it, so that's what we're gonna find. So I just took, took the matrix for it,
Oh,
and
yeah,
I put the little -1 to it, so I'm gonna take the inverse of it.
I don't know how this. I even have any.
Alright, so you need to enter in matrix A. Make sure you go over to edit, hit enter. Our new matrix for A is 2, -7, -1, and 4. Then I need to go back to the matrix a second time, go over to edit, but we want matrix B, so you need to arrow down to matrix B because it's a different matrix. And enter the numbers -21, 3, 12, and -2 in for matrix B. So I now have 2 matrices entered into the calculator. We're going to hit second quick, clear out the screen. We are solving for x by taking the inverse of A times my B matrix. Because that's how I would take the A matrix to the other side, not by dividing it, by using the inverse of it. So I'm going to bring up that matrix. So I'm just hitting enter because right now A is bold. And we want the inverse of that. So right now I have the inverse of A. And then one last time, I need to get the second matrix. So you have to arrow down so that B is bold. So right now, the calculator has information for A. It's going to calculate the inverse. And then it's going to multiply it by B. And when you hit enter, it will solve the equation for you. So we could do that by hand, we could multiply across the rows and down the columns, but the calculator can also help. Questions? Yes, so tonight's homework you can use the calculator with, because you don't know all of the steps involved to determine the matrix. Alright, so the last thing they're gonna look at, still using the calculator, is to try and solve a system of equations, instead of graphing, instead of elimination, instead of substitution. We can check the work with the calculator can solve the equation for us. So it says, write the system as a matrix equation AX equals B. The matrix A is the coefficient matrix, so we're going to take the coefficients from the actual system. X is the variables, whatever variables you're solving for, we'll solve for X and Y. And B is the matrix of constants. We need to find the inverse matrix of A, so that when we solve, by taking the A negative 1 from the left and moving it to the right, because I want to get the A by its, or the X by itself, we're going to be using this standard equation. So to get X by itself, we need to take the inverse of A times B. So just to kind of go through what this is talking about. So what it's saying is that my first matrix is the coefficient matrix. So matrix A is our coefficients in the problem. What are the coefficients in the problem? What's a coefficient? Caitlin? Those would be the variables. So what's the coefficients? 2, 3. What number's in front of X on the bottom? 1 and 4. So there are my coefficients. Then we have the X, which is really the variable matrix. So the variables that we're solving for. In this case, we have an X and a Y. X is always on top. It's your first variable in the ordered pair. Y is on the bottom. The last matrix, which is B, is our constants matrix. What are the constants in the problem? There? 19 and negative 7. That's what it's equal to. So I took the equation, we kind of rearranged the variables, pulled the numbers outside, put the variables in its own matrix, and then on the other side of the equal sign would be the two values that the equation is equal to. So we're going to use the calculator again. Now we're going to solve for X and Y. So in your calculator, you'll get two numbers. The first one on top is X, the one underneath it is Y. To solve for that, we need to take the 2, 3, 1, and 4, those coefficients, and take the inverse of it. Multiply that with the constants of 19 and negative 7. Because the only way I can get rid of this A is to multiply it by its inverse. But if I do that to the left, an equation needs to be equivalent, I need to also do it to the right. And we have to keep it in front so that the dimensions are matching up so that my columns and rows equal so that I can do the multiplication. So that's why it gets written in the front. So see if you can plug this in your calculator. I'll be around to help anybody that has a problem getting it in the calculator. But your goal then is to get the X and the Y. So your final solution, you're going to have two numbers there. So see if you can get X and Y. Isabel?
It's just a question. Whenever you're inversing a matrix, the matrix that you're inversing cannot be variables.
Correct.
Just
So tonight's homework, or over the weekend, really relies on the calculator. You have to write like the setup equation of what you're plugging in the calculator. The calculator is doing all of the work for you. I want to make sure everybody's okay on the calculator because that's really what you're be doing over the weekend with the homework. So always be mindful.
Put in the entire equation like this, and
fine, he's just not using the fact that we're trying to use the process of solving an equation. You should get 19.4 and -6.6. That should be your solutions. 19.4, -6.6. Have an awesome weekend. Enjoy homecoming. See you tomorrow night, baby.
Miss Katie, can you help me with the math at homecoming?
Sure. I'm not sure you want to do that, but I could definitely be up for that. We can have our math party at a table somewhere. No? No thanks?
Did you put our folders back in here yet?
There we go.
Thank you. No, okay.